In almost every real-world Ruby project, your code will exist in multiple files. In this chapter, we'll look at how to connect code from different files to run in the same Ruby program. If you look at any open source Ruby project online, you'll quickly notice that their code isn't all written in one file. In fact, programmers generally try to reduce the length of the files they're writing by splitting their code up into multiple files. This is partly because it's much easier to read and work on a program when the different parts are broken down into granular units of logic, rather than being written in one big file whose logic you have to follow in loops throughout the code. That's sometimes called spaghetti code, because the logic twists around so much that it begins to resemble a bowl of noodles. So in order to understand one of the main tools people use to avoid that, let's take a look now at one of the most popular Ruby projects, Active Record. Active Record is an ORM, or an object relational mapping, which means that it tries to connect objects in Ruby programs to their representation as data in a database. It's a core part of the Ruby on Rails framework, and you can learn more about it in the class Build Dynamic Web Apps with Rails, right here on OpenClassrooms. Like most Ruby libraries, Active Record keeps its code in a directory called lib. Let's look in there. You can click on the lib directory in GitHub. In here, as I'm writing, I can see two directories called Active Record and Rails. GitHub shows Rails generators, but that's just a shorthand to say that the Rails directory contains only one child directory, generators. And there's a single Ruby file, activerecord.rb. If we take a peek inside the Active Record directory, we can see a lot of files. Running a Ruby program, however, no matter how complicated, always begins with running a single file. You can see that here by navigating back up to the lib directory and opening the activerecord.rb file there. You see that it mostly contains require statements, something called modules, and a bunch of lines that say extend, autoload, or eager load. These are all just ways of saying, go get some code from another file. Thus, activerecord.rb is the file that ties together the rest of the files in lib activerecord, the directory. So in order to split up your program's logic across multiple files, Ruby starts with the file that starts your program up, and then uses one of these ways of finding the other files in your program. The first one of these we see in activerecord.rb is require. Let's see how that works first. We'll create two files. We'll call them a.rb and b.rb. Now let's run a.rb. In order to access the data that we created in b.rb, we'll use require. So now change a.rb to look like this. Remember that capital B underscore data is a variable, a constant, that we've defined inside b.rb. We're using this require method here and trying to load what's in b.rb. Now we'll run a.rb again. Clearly, it doesn't work. That's because require has special rules for loading files. It looks for your files in a global variable called load path. Let's see what's in that variable. Change a.rb to look like this. And run it again. This time you should see an array output for the value of load path. If you installed rbenv, you should see the path to your installed Ruby version. If you installed rbenv, you should see in there the path to your installed Ruby version under the rbenv directory in your home directory. In any case, you should see the path of your current Ruby version in here, but you probably don't see the local directory that contains the file b.rb that you're trying to load. As a result, Ruby has no way of knowing where to look to find that file. We need to make the directory for b.rb available inside the load path variable. We can fix this by passing an option to the Ruby command when we run our file. The I switch lets us pass in a directory name to add to the load path variable. In Unix systems, we can specify the current directory with a dot. So let's try that here. We'll pass the I switch to the Ruby command and pass the dot to that. That will tell our Unix-based system to load the current directory. Now, let's see what that outputs. If you take a look at the values in load path now, you should see your current directory here in the front of the list, which is what was represented by the dot you passed in. This happens to be the directory that I'm in. I'm in a directory called require files, which I created to run these programs. So because my current directory is now inside this load path variable, which happened by passing it here, the current directory here, in the form of a dot to the Ruby command, we can now go back to requiring our files. Let's open a.rb again and change it to require b.rb again, and to put our data as we wanted to do previously. Now if we run it with the I switch and add the current directory, we get this is from B. Now this is a little bit tedious because we always have to remember to pass this special option when we're running Ruby. In fact, we can also just specify that we want to look in the current directory right inside our call to require. Let's open a.rb again and change our require call to look like this. Remember, a single dot means the current directory. So if I put a single dot with a slash, it means inside the current directory, find this file. And now let's run it again, this time without that -i and a dot switch. And great, it works. Finally, since load path is just a variable in Ruby like any other, we can also just modify that variable using Ruby. You can try this. If you remember a little bit about working with arrays, you can stick something onto the beginning of an array with the unshift method. So I'm going to go back and remove the little indication we gave to the file system here previously that told it, in which directory to look for our file. I'm going to remove that and just pass the name of the file again. And run this without that little I switch either, and it works. So that's because we actually stuck the current path onto the load path here. If you want to see what that did, then we can print out the contents of load path again. Here. Be precise. Let's add our $sign there. And we run it. You see that load path is, and the first value in the array there is just that little dot, which is, in this context, just another way to write users Alex Cox source require files, because that's what dot means here. It means the file where I am right now at the command line. You can use a pwd command to see what that is at any time that you want. Now there's one problem with referring to the local directory from inside the Ruby file, as opposed to adding it from the command line with that /i switch. This dot here refers to the directory from which this Ruby script was run, not to the directory where the script file exists. So in our case, while we're running these from the directory where the file exists, those things are the same thing. But what happens if you navigate to the next higher directory? Okay, I'm going to go out of the require files directory into its parent directory here, which is called src. And then you run your file from there, having specified the file's nested path. So if I run my Ruby file from here, remember it was down in the require files directory, and it was called a.rb. I have to, because I'm not in this file anymore, now I have to specify that I'm going to step back down into this directory and that the file I want is in that directory. So now when I run it, the first part works again. I want to load some data from b.rb, and then it prints our load path, which is still current directory. But then when it tries to make the require statement, we get this error again. It's saying there's no such file, b.rb. So that's because it's looking inside this src directory, which is where I'm running the file from. This is a pretty serious limitation, since code is often going to be run from different places and on different computers even. So fortunately, there's another helpful constant variable in Ruby called file. File, written like this with 2 underscores on each side of it, stores the relative path to the current file that you're inside of. So we can use that to add the local directory to the current Ruby file. We'll need a special object here called file as well that has a method to expand our local file name into a directory. So that looks like this. It's a file.expand path, and you have to pass it. It's a little bit of an odd Unix-based syntax for the file directory, but basically we'll put that into a variable. And then here, instead of just current directory, which we see changes as depending on where I'm running the Ruby script from, we'll pass this local dir variable that we just set here. So what we're doing is basically asking Ruby to tell us where we are, and then passing that into the load path for Ruby. Let's go back up again by 1 directory, and we'll try to run our file again. And this time we get the data that we wanted. I want to talk about one more thing that's interesting about require, which is that require stands alone syntactically here as if it were a keyword or a special command in Ruby. But in fact, like almost everything you do in Ruby, it's actually part of a bigger object. In this case, require is just a method of the kernel object. You can think of objects as collections of data and methods. A method in most programming languages means a function that is attached to an object, and internally can access that object's data and other functions. Usually in Ruby, we write methods like this. So here we have load path, which is an object that contains that array of data, and we can call a method on it by passing this dot here, and then the name of the method we want, and then any arguments that we're going to pass into the method. This should be familiar to you from studying Ruby previously. Now, when we call a method like this, this is called the message, or this part was the example we were looking at, I suppose. This part where we, after the dot, and including the parameters, is called a message, and we're sending it to a receiver, which is this object. So this object is going to receive this message on shift. But when we're calling require, we don't have any kind of receiver here. We don't see, like, I said it belonged to the kernel object, but we don't see this. We don't see kernel.require. That's because the receiver in this case is implicit. Whenever you don't have a receiver and you just call a method name like this in Ruby without anything before it, Ruby is going to automatically call that method on a sort of invisible object, as it were, called self. In this case, self is something that inherits the require method from the kernel object. We'll talk more about this concept of the implicit receiver, that there's an invisible object here that this require is being called on, when we get into object-oriented programming later in the class. But for now, realize that even when you write a standalone method call, like require in Ruby, that doesn't seem to be connected to anything else, it's always actually a method call on some implicit object. What that object is changes depending on the context of the code you're executing. So that wraps up our examination of requiring files in Ruby. In the next chapter, we'll look at a tool called Ruby Gems that goes beyond requiring local files and allows you to import files from elsewhere on the internet.